Okay, so today we are a little bit later than we normally are getting a video out, and what I want to do is take this is really our last part that we'll make in milling in our milling section. So I want to take a part that already existed or one that we've played with before, maybe not so much in this group, but in other groups we've played with this Titan 5M model before. It's a star, and it's a 5-point star, and then it's got some tapped holes and then a diameter on the back side. We've made it typically out of some 2-inch square stock, about 3/4 of an inch to 1 inch tall, and we've just milled down the top of it. And so today, what we're going to do is we're going to build this guy right here. And so what we're going to do is we're going to take, essentially, we've got a 2x2 block. It's 1 inch thick, and so just imagine that the manufacturer or supplier has brought it to us already milled, ground, squared, extruded, however it came to us. It's already a 2x2 by 1 inch thick block. What we're going to do is we're going to set X0, Y0, Z0 on the top of this part. Another option would be to put it down at the bottom of the part. That way we'd have pretty good consistency depending on how we mounted it in a vise fixture or whatever it might happen to be. But we're going to put it on the top. And we're going to do 5 tapped holes around it. I think it got about a 20,000 chamfer going around the back or the outside of it. I put one on the bottom too. And then we've got the star. And now I'm going to back up just a little bit so you can see kind of the beginnings of this star. So this was just a star, and I'll take out a couple of pieces from it just so you can see what it looks like. So it was like that, and then we came in and put some radiuses and some other stuff around it in order to make this flowing part. Now, one of the things that I want you to think about in when you're making something like this, yeah, the design is super cool. It's a little kind of starfish looking like, and but so this is where kind of what it does starts to matter when we think about the manufacturing or the milling of it. We're going to end up with a couple of problems as we mill this part. One of those problems is going to come in this corner. So if you notice, this corner does not have any kind of a radius on there. So we've got to make some determinations on what it is that we can machine that with and still try to get as sharp of a corner as possible. The other thing that we're going to need to think about is, what does this do? So if it were, so maybe this was stamping, it's a, I don't know, it's a cookie mold, or I mean, it could be just a million different things. But it's going to be stamped out of, let's just say it's made out of metal, brass, something soft. When we machine this, we want to make sure that we're working in a way that one, it's already got drafts, so it's not going to get hooked anywhere. But also we want to think about the way that our lines run around this thing. It's better to kind of go around this part like this, or have lines that go up and down that follow the pattern rather than going around it. You run a potential if you have lines or tool marks that go around it actually gripping or grabbing that. Now, normally on something like this, you're probably going to polish it down, make it nice and smooth. But, so this is the part that we're going to make, and so I've got a blank drawing started up over here. So we're going to start from scratch, and we'll just start a new drawing here. And we will work off of the top and come in here, and we'll do our best effort to kind of just try and keep this thing in the middle. So it's a 2x2 square, and I have a drawing that will help you out a little bit. So here's what the drawing looks like. It's really hard when you've got a molded form like this to come up with the exact shape that you're getting from it. So what I've done is I put 5-point star based off of a 5-point polygon on a 1.95 bolt circle. Inside radiuses here are 1.7 or 0.175. The outside radiuses, or the outside corners, began as a 15 thousandths radius. They change as we go. So the bolt hole circle is laid out here. It is on an 1.5 circle. Let me just add that into it as we go. Put that in here. .5 diameter bolt circle. Those are equally spaced in between that, and we'll do an array or a circular pattern for that. Overall height of this part when we're done is 3/4 of an inch. It's 2 by 2 on the outside of it. These holes they get tapped through. It doesn't say anything about the chamfer on them. We're going to give them just a little bit of chamfer just to play with. Or we could just drill and tap them, and then we could know that we're going to use a cordless or some other chamfering method afterwards. But you can see we've got chamfer on the front side and the back side. So this is the information that we have to make this part, and we'll get back to our drawing that we're working on. So I went ahead and started my part with the center of it being X0, Y0. So at this point, what I'm going to do is I'll finish the sketch, and I'm going to go ahead and rotate it just a little bit so I can see what's happening here. I want my form to go down, and I'm going to go down by 375. So that's half of my thickness. Oh, wrong way. Half of my thickness of my part. So I'm going to put another sketch on top of that. That'll be my star. So this takes care of this guy right here, and bring him back around. I'm not sure why he's red today. I guess the other day I was playing with some different colors. So I'm going to set you right there in the front, and I'll start a second sketch. It's going to go right here on the front of this thing. And I think what I'll do, just to give myself a little bit of boundary here and give myself an understanding of what it is that I'm doing, is I'm going to go ahead and put this circle in, and I should have mentioned it while I was making it, but I didn't. I hit enter too soon. So 1.95 on that circle, and so now I'm going to go in and I want to put a polygon in there, and I think I want to put, and I'm going to have to play with this for a second. I think I want to put a polygon starting in the center here. It's going to come out to this edge. 975, and then I want to tab over, and I want 5 points on it, and hit OK for that. Pan up just a little bit so we can get in there and see what we got going on. And from this point on, if I've got my polygon created, I'm going to go ahead and just take some lines and just really connect some dots. So I want to go from here to here, and I want to go from here to here, and I'm going to go from here to here. Let me get in there so I'm getting that corner. Yep. And then I'm still in the line command. I'll go from here to here. And finally from here to here. Okay, so it looks a little pentagram-ish. At this point, I'm going to go ahead and start trimming some stuff out. I can start erasing some things, trimming things as I go. So just going to start trimming some stuff off of here. Don't need this, 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 this. Won't need this. Won't need anything in here. And that should take care of my star. At this point, I think I'm going to try to leave that circle on there just as a future possible help as in making some other parts of this thing. I need to have a 175 thousandths radius on this inside corner, and then I need to have a 15 thousandths radius on this outside edge. So what I think I'll do is I'll go ahead and put those in now. But what I want to do is I want to go ahead and save this thing. And so I'm going to call it 5M modified for video. And so why it's 5M is because it's one of Titan's the CNC's parts, and we're just taking it and playing with it just a little bit because I've told you 1,000 times I have zero creativity, and so this just gives me something to work off of. Typically, if I see something that somebody else has, I can take and modify it and make it, but I don't really come up with things on my own. Good. So let's go ahead and grab some inside radiuses. So right here, and we'll go 175. Go there, there, this guy. I got one more to do right there. Okay, and then enter. Got all those taken care of. Now, this is probably one that will cause some potential of questions. And so what we're going to do is we're going to put this radius here. It has a 15 thousandths radius on it, but if you'll notice, what it actually does is it really makes the star smaller in shape. Now that's okay because the star is based off of this other circle, and that's okay that it's like that. It still starts on that 1.95 circle, so we're still good to go, even though this one, if we were to make this and then measure it, you would see that it was smaller. So but it's still center point. Sharp point would come out to that edge. Even if you didn't put these radiuses around there, just deburring these edges would cause them to be slightly smaller, and 15 thousandths is a pretty small area anyways. Okay, so we can go ahead from this point. I'd say we should be able to finish that sketch, give it a quick save, and we can go ahead and extrude this thing out. We're going to bring it up by 375. And those two are joined together, and now we have a nice little star. I should have done colors of red, white, and blue so that we could be patriotic, but I didn't. And so what we got is what we got. Okay. So let's see, we could put this thing here, and now we need, I'm going to flip it around to the face, and let's pan that down just a little bit so we can see it. Okay. Need to go ahead and get our bolt circle put in there. Our bolt circle is based off of a 1.5 bolt circle. We're going to drill and tap 1/4 through. So here we are. In order to get that, we need to put a single hole in a position in a spot. Okay, so we're going to put a single hole right here. And we can do kind of either way that you want to do this. I might go in and position it first, 1 inch. And then I'll go from here, maybe from the middle, or even from this edge here. I know I can grab it. Rotate that around just a little bit. Nope. And we're going to go from that corner is going to be 0.25. Okay. So I prematurely hit enter, so I just go back in here and I can double click on this thing, get back to that hole. And so my diameter is either going to be through or 0.75, 375. It is going to be a tapped hole. I will put a chamfer on the top of that. And let's see, I want that to be about 275. So I've got a small problem there at 275, and so I want to go 90 degrees. Occasionally, and we talked about that when we met as a group the other day, sometimes you can get that, or that chamfer diameter doesn't quite jive. So what I want to do before I go and try and play with it is I want to make sure that everything else is set up correctly for it. And so it's still giving me a problem with that chamfer. It looks like it would take something else, but having a little bit of problem there. A lot of times I can cancel out of it and then come back to it, and it is just not going to let me do that. So I could probably go smaller with it, maybe 185. Nope. Let's see if I went 205 if it would take it. No. So I'm going to just leave that out of it. And so I'm just going to make it a regular hole, still 1/4. And I'm not going to model it. And I mean, if I was going to 3D print it or something, I'd model it. But I'm not going to do that. And so what I'm going to do is I'm going to go ahead and take, at this point, just do a quick save. So I've got this one single hole. Now I chose the bottom hole just because it's really the simplest hole to do. I could have done any of the 5 holes there, but This one is kind of numerically and dimensionally just really placed in a really good spot for me. I'm going to go over to my threading, or I'm sorry, my pattern for making my hole pattern. And I've got a couple different places that I can do that at. So this is the one that you see a lot of times. But we're going to make ours a little bit different. So we're going to go down to pattern, and we've got rectangle pattern. That's the same as what we saw up there. And then we've got a pattern on a path. So that would be if it flowed across something, we could set something so that it kind of flowed with the pattern. But we're going to do a circular pattern. And it's going to be a circular pattern based upon this face. And it's going to be this object. Probably would have been smart to go ahead and chamfer that hole, and then I could have went ahead and just carried that chamfer throughout the entire thing. Let's see, on the axis that I want to select, I want to bring it right into here. Nope, so I got a problem, right? One, I've got the wrong amount of holes. Two, my objects are causing me a problem. So I'm going to erase those objects. I'm going to get into that hole and select that as my object. Now things look just a little bit better. Hit that. Like I said, I should have went ahead and put a chamfer in previously, but I didn't. And so we're going to go ahead and just catch it as we go here. And so we'll go 1, 2, 3, 4, 5, flip it upside down, 6, 7, 8, 9, and 10. I want that chamfer, let's just make it 20, just so I have some nice broken edges there. Hit OK, bring it back around to the front, top. Okay, now we got our star, and we'll save it. If you're wondering why this took longer to get done, it wasn't because I was on the beach taking vacation. It was because this week we spent in preparation. Believe it or not, we're way ahead of you guys. Is already coming back for the fall semester, which will be on ground. And while we're doing that, we're updating software. So we updated Fusion. For me, Fusion takes a lengthy process. It's not as simple as yours because mine goes through the network and then about 150 people have to somehow check it and okay it, even though nobody actually even looks at it. So we had to take care of uploading or updating Fusion for myself and my laptop and all the stuff that I use throughout the day. So my 3 or 4 computers that I use, and then we kind of talked about just some plans for coming back into the fall, and then we also updated the CMM, which is crazy because we just did a huge update to PCDMAS 2019 release 3, and now we are already in 2020 release 1. So I just got myself familiar with 19, and now I just got started over with 20. It's a hugely different program than what we had before when we were running 2013, so that's a pretty big learning curve. But as we're putting together, or as I'm making new videos for that, today I should be able to get some stuff posted out so that you can start working through some of our hexagon modules and start to understand PCDMAS. PCDMAS is by far the leading software manufacturer for programming, and if you can learn PCDMAS, you can learn just about anything else. So okay, so let's get back to where we were. One of the things I told the guys in class the other day when we were having our group is that I was going to put something in here that just to make sure that you guys are actually watching the videos, and I was going to put just a really small just a note saying, hey, if you are watching this video, just stop now, turn it in, and I'll give you 100% for it. But that would really be shortchanging you because we have not got to the 3D contour on this part. Up until now, we've got just pretty straightforward, a little star on a block, which would be great for if you're into stamping, or if you're into scrapbooking, and I know several of you are, you guys are the type of guys that would probably love scrapbooking. And this would be great for that, but that's not what this is going to be. So what we're going to do is we're going to come in and we're going to do some modifying to this. We're going to put a draft around the outside of it. So draft for me was 100% brand new. I've never messed with it before. And so the other day when we were in our group, we just thought, hey, let's just play around with some different things. And so here's what I'm doing is I'm using a pull method in draft. So you can do a parting line where it might go two different directions. This is a pull method, so it's coming from this face. You can see the arrow where it's derived from. And that's where the draft will come from. And then the faces that we're going to go to are going to be these. I think there's 20 faces maybe around it. And so you can see already, so I had already selected 35 degrees in there. You can change it to whatever it is that you want on or let me just say this. You can't change it to whatever you want, but it can be changed to a multitude of different angles. We want 35 degrees on our part, and we want it to pull from one side. So we're good up till there. And so it's pretty cool looking. I love the way the Fusion does shadowing. It's really, really intuitive on those types of things. The only thing we have left to do on the outside edge of it is we need to come in and we need to radius it. And so we need to put a fillet that runs up this leg, up all of these legs. This one doesn't look like it got hit. I hit it before, but it didn't quite take. So we're going to go with the 100 thousandths radius on that. And so we get this sweet curved piece. And man, I love that. It makes me want to machine this part. I'm not going to, but it makes me want you to machine this part. Let me say it like that. I have been spending some time at the school. You guys are still strictly forbidden to be on school property, but I am able to work my little tail off there, so I'm in there several days through the week trying to get some stuff caught up and get ready for the fall semester. It will sneak up on us really, really quickly. Okay, so here we are with our pattern. We've got our whole part made, a whole part modeled out. It took just about 20 minutes, and half of that was me talking. So, man, if you came from a land where building models, or you drew not model-based, but you drew dimensionally, or you were driven by dimensions, then this world is really unique and so much smoother to work with. So we've got this part. You can color it however you want. You can do that in appearance. We'll go ahead and move into manufacturing side of it, and we'll go ahead and get started on that part. Okay, so we can come in here, we can look at our setup. Oh my gosh, how awesome is that? It came right back, or came right to something about what I wanted, or really close to what I wanted. Again, we try to run our ribbon left to right. We'll also try to run all of our components top to bottom. That keeps us from losing something along the way. So we can go ahead and choose our machine now if we want to. We're going to go in and try to fine-tune what we've got in our machines. We're going to do a milling operation, and we're going to find our Haas AB. And this is, so here we've got a rotary on this one, so it just has an A axis, and here's one with an AB, so it's 5 axis, so it will work just fine. So it's typically a UMC 750. We can use it, and even if you're running on a 3-axis machine, which you can easily make this part on a 3-axis machine, then you're still going to be able to use this post for that. And we've talked about that before. Just because it has extra in it, it doesn't mean that you can't use it. Here's a VM3 if you want to just be in 3-axis. It looks like this one has a TR 210 on it, so it looks like it might have some additional rotary stuff going with it. But this seems to be the one that I use probably more than anything, and so we'll select it. And our operation is milling, and our orientation happened, we just lucked out on this thing. It's going to be right in the middle of this thing. So we've got our part. The only thing that we need to do is we need to change some stock around it. We've got our body if we want to. Yeah, we can put that in there. So we've got that. Whoop, grab that body again. Okay. And then we can move over into stock. And so we could actually choose a fixed size box. And so on this, and that's something that you can play around with, but what we want to do is we want to go 0 side offset. On the top of this part, there is going to be offset. So this part is going to be, it's going to be 1/4 of an inch taller. So we had said that this part came in to us as a 1 inch by 2 inch by 2 inch block. And so, various reasons for that. I mean, who knows why the manufacturer, knowing that this part was going to end at 3/4 of an inch, why they would send it to us like that, but it doesn't really matter. That's what we got, and that's what we got to work with. So we've got a couple different ways we can rip some of that material off of it. Depending on the tools that we're using, it's going to be no big deal anyways. So we can double check down here. We've got a 2 by 2 by 1 inch block, good to go. We can go ahead and put in a program number here if we want to, and we're going to say it's 7896. It can be whatever you want. Make that up as you go. I'm going to go ahead and use 3 for my offset, just so I can change it up just a little bit. If you would, when you post out your program and you send me your assignment, I want the Fusion file. I want the NC file, and one thing that makes my life a lot easier, if you would include this into it, if you would include the setup page on there, it would be really, really, really nice, and I would be very appreciative of that. So we've got our setup, and so now if we wanted to, we could go ahead and fine tune some stuff, but we're actually going to have to come back here. So I'm going to go ahead and skip that for right now. And I'm going to go in and start to do some machining around it. Now, I've got to be kind of mindful about what it is that I'm doing on this part. I'm not going to machine the outside of it. I'm only going to mill down on the top. I need to come in here and just rough this thing out. There's a couple of different ways I can do that, but I really kind of need to be thinking about what kind of tools I'm going to use for that. And this radius right here is the thing that's going to help me determine that. If I come in with a 1/2 inch end mill or a 2 inch shell mill or anything like that, and I could rough it out with that, but I can't get this corner radius here, so I've got 175 thousandths in the corner radius. Now, if I had a really slick 3/8 end mill, that's probably going to be about my best choice to use, or I could rip off some of the top of it off. I could even, if I wanted to, I could really play around with some stuff on top here. So maybe I wanted to go to adaptive clearing and select a tool. Whoop, showed up on another screen. So here's Fusion's new tool library. It's really no different or not much different than what you had before. I mean, it looks different. And here's something that we talked about the other day as we had our group that met face to face. One thing I want you to think about is, I know that you would love for everything to stay the same all the time and never have any, change-ups in software and updates and tooling. We happen to live in a world that changes all the time. So if you're frustrated that Fusion did an update, buckle up, because they seem like they update about every 30 days. And this one here, this tool library was a big update, but what this does is this helps you to not get so rooted in a one particular style of tool library. You might find yourself going to a manufacturer or just a job shop that uses 2 or 3 different CAM systems, and so you need to be able to be fluid enough to jump into different things. So I still have, whenever I did my update, I came in, grabbed my SFCC tools, everything transferred okay. And then we've got that to work with, so I'm going to use my 3-inch shell mill for this. I'm just going to play around with this for a few minutes and see if I can remove some material without really kind of getting in there and chomping away at so much stuff. So Looks like everything here is okay so far. One thing I do want to do is I want to go ahead and change around how deeply that this goes into it. And I'm going to do that by changing my bottom on this thing. I want my bottom to go, from the model bottom, I want it to go up 375 thousandths. That means I'm not going to mill down anything lower inside of here, okay? Let's leave the other things alone and just for the heck of it, see what happens with this thing. Okay, so this 3-inch shell mill did everything that it could, and it looks like it did a pretty darn good job. Let's just kind of simulate through that thing and see what it looks like. Oh, turn stock on. So huge cut in the beginning there. That's not a problem. From there on out, we're kind of doing, looks like we might be doing a spiral path down, or it looks like maybe not spiral, but we're stepping down as we go into this thing. So this is easily done with the shell mill that we have. Now, if you're on a machine that wouldn't quite work with, you can adjust the amount of steps that you have. This part, we would be making it out of probably some 6061 aluminum. That seems to be our go-to or our favorite, so we could leave that alone there. Okay, so this does the outside shape of the star. Okay, so let's just say for right now we leave that alone and say that we're happy with that. We might keep with it. We may not. But next thing that I want to do is I still want to go into adaptive, and I want to do a second adaptive cutting, and I want to grab a different end mill. So I'm going to grab a 3/8 diameter flat end mill. This one happens to be overall length is 2.5 inches. Looks like it's a 3-flute end mill. Probably would change that. Also, I haven't seen what type of material it is. So I'm going to go in and just edit that one real quick. So right click to edit and go in and change that number of flutes to 4 and go ahead and tell it that we're working with the carbide end mill. Okay, and so we'll just change that. And then that's still our tool. I can go back in here and double check that it's got the things that I want. And I can see that it's now carbide and it's now 4-flute. So we're gonna grab it. And then let's go in, play with this just a little bit. So we've got our rest machining turned on, and then stock to leave. We'll leave 20, maybe 10 radially, and then I'm probably going to go ahead, if I can, go ahead and bring this down in Z all the way for milling on the top and the face here. Go ahead and let it take it to size at that point. So let's see what that looks like for the generation. Probably am not 100% happy with all of those moves. So we've got our upper path up here. Here's why I'm not going to be super happy with it. So I've already roughed out this section out here, and then I've got a little bit of air cutting going on around here. Now, time-wise, we're probably talking about not a lot of time. Let's look at our machining time for that. So we've got 1 minute and 16 seconds on that, and that we have not really done any kind of feed and speed optimizing, but let's just say that it does. And a minute's not bad if we're making, you know, 1 or 2 parts, but we could probably go in. We'll probably go in and do some tweaking on that. Edit that thing just a little bit. Grab it. Look at our step down on this thing, or maybe even. Let's go down and see our step of 370 or 393. That one we could probably leave alone, and I am going to move this back up to 375 there, just again to keep that from going down any further into it. We'll play with this as we go, just to kind of help ourselves out as we move along, just to try and speed this thing up. There's a couple of things that we can change as we go through here, but we'll just kind of take a couple of quick looks at a couple of different things. So I'm going to leave that one alone for right now. Remember, we also have not changed any of the tool numbers on there if we want them to run in a certain direction in the carousel. So up until now, this has also not solved a couple of my other problems. The only thing that it's done is given me a depth here, and it's given me a finished face here. I have not brought this section around the outside of it to size. Probably the way that I'm going to do that, or I'm going to attack that today, is I'm going to do a contour around the outside of this part. And so in doing that, I'm just going to go into contour. I'm going to use that same end mill. Let's see, 6,000. Just looking at speeds and feeds on it. And let's come in here. No, I don't want to leave any stock. I want to take this to size. Actually, now that as I'm saying that, I may change that up just a little bit as I go. So I'm going to check this contour here, and I want to see what it looks like, and then I'll probably come back and do something just a little bit different with it. Okay, so we're going to hit OK for that, and I'm going to simulate this whole part and then see how happy I am with it. Okay, so here's the part that I'm super unhappy with. I'm okay with some of the other things that had happened, or I'm at least willing to let them live with them for right now. What I'm not happy with is the fact that I've got this tan line as my 2D contour that I just took around here. This blue line is everything that happened from the tools before. Now, perfect world, there would not be any kind of mismatch from there, but I know that just tool pressure alone can cause me a couple of problems. So what I'm going to do is I'm going to come back in, I'm going to grab this tool, and I want to, I could do it two different ways. I could go in and leave some stock. So I could come in here and I could say leave 0 for radial, and then I could say leave 2000s axial, and that should help me keep off of that face just a little bit. So now as I run this thing back through graphically, see, I get just this outside edge being grabbed to take that thing into size. Okay, so that's one way. Another way that I could do it is go back in. I could go here. I could go here. I could select the bottom of the contour and just offset it up a couple thousandths from there. So you'll see me select model bottom a lot and then go back up to 375. I could go 377, or I could select the contour and move up from that if I so chose to. I'm okay with leaving just the axial on that. All it's doing is just going to keep that off of the bottom just a couple of thousandths, maybe even 1,000ths would be enough from that. Go ahead and hit save as I go here. So man, we're making pretty good time through this part. I'm going to go ahead and flip it back around so that we are back up. Now at this point we have got a pretty good chunk of this part done. We've modeled it out. We've made a really sweet looking part. And so we also have, we've got this thing roughed out. We've got the outside contour finished. What we need to do now is tap holes, and then we need to do some finish milling of the actual shape itself. And so what we're going to do is we're going to go into a 3D, and I think that I did a, oh gosh, let me go back in and look at my other one. There's my original one that I had, and I went in and did it as a parallel cutting. And why I chose parallel cutting is I want it to work in a way so it's going across, and I'll show you it just real quick. And so if you notice, it's going up and down over those legs, and what it's going to do for that is it's going to help keep some of my tool marks in a direction that works pretty good for me. You know, probably running parallel would even be a better way to do it. What I don't want to do is really go around that part. That's probably the one thing that I'm trying to stay away from, probably more than anything. So we can kind of play around with some of those things right there. And so we'll go into our 3D and we can do, let's look at parallel. So we're going to use a different tool. We're going to have to go in and do something small. 1/8 inch ball mill would be a really good one to do. So full ball on 1/8 inch diameter. This one's probably high speed steel. It's probably not a carbide end mill. It's 3 flute. I think it probably is 3 flute too. So I'm going to go in and do a quick edit to it for material wise. In unspecified, we're going to go with high speed steel and hit that and then select it. So I've got my tool selected, and then what do I want to do? I can come in here and I could do a selection. And I want to come in and grab the actual part that I want to machine. And so I'm going to go back to, not my drawing, sorry, design. And I want, no, I need to go back to manufacture. I want the actual part itself. Try and grab it. Which came out of there. I'm gonna grab that again. Go. I think it shows parallel. Got our tool, and we're gonna grab the selection of this thing. Go ahead and that's probably gonna cause us a problem doing it like that. Let's try it and see what happens. That's not going to allow us to get all of those things. We're going to come out of that. That's not going to do what we want, or at least that function isn't going to do what we want. So we're going to go back into I would let you play with this one just a little bit as to how you do it. And let's go back to mine again. And so I did mine as ran it as parallel, and let's go back and we'll grab parallel and just play with it just a little bit. And what I want to do is I really want to grab just the model of that. I don't know that I can grab it like this. We can try that. No, that's not really going to go. It's not going to do what we want to do. So let's grab the selection of that. I'm not sure that I'll be able to grab it just like that and go from there. Let's just try it and see what it looks like. Yeah, so it's machining most of the shape of that, but we've got some huge problems with running over the top of it. And so what it's giving us is really not a true and accurate look of what we want. So what I want to do is I'm just going to come in here and just do some modifying to this. A lot of times, especially when we're working with a kind of a 3D form like this, it's just not going to do what we want the very first time. So Instead of, we chose the selection, I'm going to go ahead and go with silhouette on this, see what it looks like there, see if that looks any better. Okay, so it's jumping over in the path and the pattern that I want it to go, but you can see really the step over is pretty significant, and obviously that's not the kind of part that we want when we're done. So we'll go back into that. We want to make sure that our step over is much smaller. So we want to come in here and grab all of our options and make our step over something maybe like 5 thousandths. Now 5 thousandths might not really be what we want to keep it at, but it's definitely someplace that we want to start with. Okay. So let's see what that looks like. So it takes just a little longer to generate something like that. And you can see there's tons and tons and tons of toolpath that goes on it. So let's see, start to finish, what this thing looks like. So there's our tools as they go through there, so it turns some of that stuff off. Probably the only thing that I'm unhappy with is the fact that step over wise, it looks okay. I mean, you can still see, even at a 5,000 step over, there's some areas that it's not super smooth. But here's what I don't like is the fact that I am running into that face some. So I'll go back into that. Pull it off from the bottom just a little bit. Got 377 off the bottom. As I'm looking at that tool, let me go in there and look at that. I've got some issues with my, okay, here we go. So my problem, part of my problem is that I must have deselected my tool and then never went back. So there I've got my tool again. Let's see what that looks like just a little bit better. Okay, so my step over needs to be much smaller. Go back to 5, stand by. Now we're getting a little bit better step over on that thing. 377 from the bottom. Let's see what that looks like now. A little tighter. Still staying off the bottom. So now we've got these nice lines that run up and down here. You still have some small issues going through there. Let's see what it looks like as we go through it. Simulation wise. Yeah, it's not terrible. It'll take a little bit of polishing to make that thing totally smooth. Let's leave that alone and let's add in another option of going. We went parallel. Let's go. Oh gosh, I don't know. Let's go radial and see what that looks like. I don't think that it's probably going to do what we want. I think we're going to probably have some other problems with it, but we'll try it. And oh, we've got that same tool. We don't even need to select it. And let's just see what this thing looks like if we do that. Okay, so it's a little bit better as far as the machining on the form itself. Let's go back in there and play with it just a little bit. Machining boundary, tool containment, center points. Tool containment would be, let's just say, tool on the center of the boundary. We'll keep the tool inside of the boundary. Let's try that and see if that pulls in a little bit tighter. Not really. So, because what's happening is it's grabbing this entire section on there. So let's just see if we could make it a little bit better on that. So making an additional offset would help square it up just a little bit. That would be one way to take care of that. We'll go up to 377. And we really want to just try and grab just that one part. But if we come in here and we put any type of selection to it, it's probably going to be much harder. We can try that and see what that looks like. Yeah. So let's go in. That looks really good on the top, but let's just try to play with that a little bit more. And we'll go back in. We had put this boundary to it. We'll go tool center on boundary. See what that looks like. That comes out much closer, but still you can see it doesn't come all the way down to it. And we need it to come all the way down to it. Now here's why it's not going all the way down to it. You've got, I'm going to come in here and just change up my view just a little bit. Part of the reason that we've got that is because we're working with a tool that has a radius on it, and that's going to cause us some problem in there. But when you're trying to make a 3D form like this, you're going to have to use some type of a ball tool to do that. So let's see if we can get in here and play around with it just a little bit. And this is the first time that I've played with this, and I would encourage you to just mess around with that just a little bit. Just a little bit in this 3D form and see what you can come up with, something that you might like just a little bit more. It's probably about the best that we're going to get. It's going to come as close to it as it can. But remember, we are staying off the bottom of it just a little bit. So maybe I would get rid of parallel, keep that one. Let's just do that. See what we end up with from there. And I'll go ahead and run a quick graphic over the entire thing. Okay, that looks pretty good, and that keeps that form flowing the way that we want it to. Close that. Total machine time right now is about 9 minutes. We have not done our drilling and tapping yet for the part. Let's go ahead and look at it. I don't have hole recognition purchased back in my new revision or my new version yet, so I'm just going to go in and do these holes automatically. I'm going to say, or individually, I'm going to say that I'm going to hit my chamfering on the top and bottom side with the cordless, so I'm going to go ahead and just drill them and tap them. So by doing that, go in and change tools. I have a 201 number 7 drill already selected. I'm going to do a drill in deep hole. I'm going to pack 75 thousandths as I go through there. You can do some change ups on that. You don't have to do it just the same way that I do. Just make sure that it goes all the way through and that it is getting it's getting down through there. So I'm going to go down beyond the whole 50 thousandths. Okay. Oh, guess I better tell what it is that I want to drill. 1, 2, 3, 4, and 5. Okay. And I've got my drilled holes almost done. Okay. So what I'm going to do is I'm just going to go ahead and take that and I'm going to duplicate it. So I want to go through and just, I've already got everything really set up for that. So I'll just duplicate that and go in and edit it. And I want to change tools. Now, the thing about duplicate is you do end up changing a lot of things, but it does keep me from having to select those holes again. And let's see, do I have a, not sure if I have a 1/4-20 tap set up, maybe in here somewhere. Looks like I don't have one set up, so I will need to go in and find a 1/4-20 tap, and we're going to do right-handed tap, and we will, nope. Okay, so it's grabbing 3/8 taps because it's only going from the ones that I have. So I'll just jump up in here, and I gotta have this 1/20 that I use. I've already got my holes selected. I've already said that I'm going down 50 thousandths beyond, and I just need to change this to tapping with no chip break. And so we are not going to do any kind of peck with that. We're just going to say, or I'm sorry, that was tapping with chip break. We're going to go no chip break on there, and go through there at 500 RPM and grab that, put some threads in those holes. Now, if you would, I'd like you to number your tools from 20 down. So make this 20, 19, 18, 17, 16, and 15. Work like that. I will let you adjust your speeds and feeds to whatever it is that you want, so that you can kind of get some optimization in here. If you're using some nice carbide tooling, obviously you can go higher RPMs, higher chip load, feed rate on there. So play around with that, and then what I want you to do is I want you to submit to me your complete Fusion file. I want you to submit to me your setup sheet, and I want you to submit to me so your Fusion file, your setup sheet, and your program. The only thing I haven't done is I need to go in here and just, I think I called this 7896, just to keep that jiving across there, and operations are going to be everything. We're going to do all of it. Let's go back here. Only thing that I really want to know as I post this out, I selected for my WCS, I selected 3, and I just want to see if we went ahead and grabbed that in there. Oh my goodness. So go ahead and after you get all of the things that you need to installed, go ahead and post out your code. I'd like you to use an offset other than 54. So 55, 56, 57, 58, 59 will be your choices. So look for that on your work offset line. Everything else should be the same. Remember, I want you to go 20, 19, 18, 17, 16, and 15 in your tool numbers, and use a work offset other than 54. All right, so that is your assignment. This is the last assignment in milling. We'll be in turning starting next week, and you'll have this assignment won't be due this Sunday. It'll be due the next Sunday. Look also for an additional assignment to show up inside of this module in Canvas. Last week you did 2, and I feel like you can do 2 as well. So I will see you later.